Rabbi shrah li sadri wa yassir li amri wahlul uqdatam min lisani yafqahu qawli. A'udhu billahi minash shaitanir rajim. Bismillahir rahmanir rahim. Subhanallahi walhamdulillahi wa la ilaha illallah wallahu akbar. Wa la hawla wa la quwwata illa billahi al-aliyyil azim. Allahumma salli ala Muhammadin wa ala ali Muhammad. كما صليت على إبراهيم وعلى آل إبراهيم إنك حميد مجيد. Guys, in this video I will derive the maximum and minimum velocities for skidding and overturning for super elevation design of highways. Okay, the figure that I will use is figure 18 that you can see on the screen. Bank turn, Tahir super elevation design of highways for both skidding and overturning. The two equations for skidding you can see on the screen, Vmax and Vmin. We will derive these equations. Okay, first we will derive the maximum speed of vehicles on super elevated bank turns on highways, motorways for the case of skidding. This is just a recapture. Summing up forces in the y direction. Okay, so the x and the y direction are shown here. The y direction is normal to the plane. The x direction is along the super elevation. So we have n plus mv square max over r cos theta minus blah blah blah. Summing up forces in the x direction, I have this. So we have this, n is equal to this. This is just recapture. I have done it previously in my previous video. Okay, the frictional force is mu n, f is equal to mu n is equal to blah blah blah. Substituting the value of the friction force into the second equation above, I have. So I get this equation, and then I get this equation, and then I get this little bit bigger equation, separating the cosine and the sine terms. So I have eventually tan theta is equal to, so this theta is for the max. Separating the cosine and sine terms, I have tan theta is equal to mu s g minus mu s v square max over r minus v square max over r, divided by blah blah blah. So V max is equal to gr tan theta plus mu s over 1 minus mu s tan theta plus 1 plus mu s. So this is for the V max. Similarly, I can find the minimum velocity required on the bank by considering the friction force in the other direction as follows. So if we reverse the direction of the friction force, we will get for the expression for V minimum, which is gr tan theta minus mu s 1 plus mu s tan theta 1 minus mu s. Okay, so the theta max here is less than tan inverse mu k g, g1 minus 1 plus mu k blah blah blah. Okay, so for the well of death at theta is equal to 90 degree, only I have the maximum minimum velocities in the world as below. V max is equal to gr1 minus mu s square root. V minimum is equal to square root gr1 plus mu s for mu s less than 1. If there is a, guys, this is very important. If there is a traffic jam on the bank curve due to an incident ahead or some other reason, then the car velocities must come to zero. Therefore, the condition for the minimum velocity speed should be as follows. V minimum is equal to 0 tan theta, or theta max is equal to tan inverse mu s. So theta must be less than tan inverse mu in order for cars not to slide upon each other towards the down end of the bank turn. During a complete traffic jam, like the wall of death, theta is equal to 90 degree greater than tan inverse mu s, where we need a minimum speed to stay on the wall because the friction in the opposite direction of falling would not be sufficiently enough to hold the vehicle from sliding or falling. You got it? Okay, good. Similarly, minimum velocities can't be maintained on the bank turn in the case of total traffic jam when theta is greater than tan inverse mu s. Since the minimum speed limit should never ever be considered for design purposes, hence the maximum limit on theta, the angle of bank turn, is theta max is equal to tan inverse mu s for skidding. Okay, guys, skidding means slipping. Slipping means friction is involved. The above values of minimum and maximum velocities are also the values for the conditions of skidding of the vehicle, either towards the upside of the bank turn or the downside. However, after incorporating the minimum velocity condition for total traffic jam and replacing coefficient of static friction with the coefficient of kinetic friction, I obtain as below. So theta max is less than tan inverse mu k, coefficient of kinetic friction. To do the overturning analysis of the vehicles, particularly high trucks, I need to consider two important dimensions. So this is new. This is new in this video. The Tahir superelevation design of highways for overturning, which is usually skipped in Astro, in Wikipedia, in physics of Newton, or classical uh, ideas. Yes, stuff like that. Okay, so to do the overturning analysis of the vehicles, particularly high trucks, I need to consider two important dimensions of the vehicle from the center of gravity of the vehicle. That is B and DS in figure 18. So B is half of the width of the car between the tires, and D is the depth of the center of gravity of the car from the ground, from the super elevation, from the surface of the road. Okay, so when this, for overturning, we'll consider the condition as soon as the vehicle down tire loses contact with the surface of the road. So the down tire or the left tire, the one that you see in the figure on your left. When this happens, no reaction, normal reaction of the road is transmitted to the vehicle through the up tire in contact with the surface of the road. Okay, therefore, taking turning movements around the point of contact between the up tire is the tire on the on the right side of on your right side. Between the up tire and the surface of the road, I obtain as follows. Okay, Vm v square max over r times b plus d tan theta times cos theta plus mv square max over r d secant theta minus b plus d tan theta sin theta is equal to mg b plus d tan theta cos theta. From figure 18a, we see that 18, not 18a, 18, we see that only two movement arms are needed to take movements above the turning point. The right tire of the vehicle as shown in the figure above and as below. So with respect to the right tire, only two movement arms are taken into consideration. So d b plus d tan theta blah blah blah. So solving for Vmax, we get grb cos theta plus d sin theta d blah 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 blah. Vmax is this. Then Vmax is equal to gr tan blah blah blah. Okay, so the final expression that we obtain is this guy. This expression, guys, is very similar to the one obtained for skidding. You see the similarity in nature, in natural philosophy, in natural theory of relativity, inertia, gravitation, and gravitativity. Do you see the nature working in there? Open your eyes, please. Sleeping for the last 300 years. Okay, so where gamma is equal to b over d. Oh, okay, so let us describe for the first time in history the coefficient, and let us call it Tahir coefficient of gauge, T cog. Gamma is equal to b over d. So eventually we have this expression. So v should be greater than or equal to 0 and less than is equal to square root of gr tan theta plus Tahir coefficient of gauge divided by 1 minus Tahir coefficient of gauge tan theta plus 1 plus Tahir coefficient of gauge for overturning. Okay, so for skidding, we have this one. Just look at the similarity that nature provides for you. Theta max, look how the equations of nature, bending moment, turning moment, and overturning and summation of forces, how similar they are. Look at the symphony and the rhythm of nature in these two equations. Okay, so theta max is less than tan inverse mu k for sliding, and theta max is less than tan inverse Tahir coefficient of gauge for all vehicles and cars in the 7 heavens and 7 earths. Okay, similarly, we can derive the expression for the minimum speed for overturning to happen at the inner tire at a certain superelevation. To do so, we need the following two turning moments arms in this case as below. In this case, the movement arms might be a little bit different. For overturning, we will consider the condition as soon as the vehicle up tire, the tire on your right side that you see on your right side in the figure 18, loses contact with the surface of the road. When this happens, the normal reaction of the road is transmitted to the vehicle through the down inner tire or left tire in contact with the surface of the road. Therefore, taking turning moments around the point of contact between the inner tire and the surface of the road, I obtain as below. Okay, so I obtain this equation mv square minimum over g d tan theta minus b cos theta blah blah blah. Okay, so v minimum. So you see that the turning moments, they are also very similar, only except there is a sign difference. Yeah, only except the difference in sign. The rest is I think the same. db plus d tan theta cos theta d secant theta b. No, there is a sign theta difference as well. So they are not exactly the same. They are a little bit different. Yeah, a little bit different. Okay, so then we obtain this Vmax. So Vmax is gr tan theta plus gamma. And do you see this? Its similarity with the Vmax for skidding? Very similar. Okay, so where gamma is equal to b over d, Tahir coefficient of gauge, T cog. Okay, so theta max is less than tan inverse gamma g plus 1 minus gamma v square over r, g minus 1 plus gamma v square over r. Or in a better way, we can write the above four inequalities as below. For skidding, up tire. For Vmax, theta less than max less than tan inverse. For skidding, downside, down towards down tire. For minimum, V minimum, theta max less than tan inverse. Overturning on the upper tire. For Vmax, theta max less than tan inverse mu. Overturning for the bottom tire, the left tire. For minimum down tire, the theta max equal to tan inverse. Okay, skidding unrestricted or overturning at outer tire. And here, skidding unrestricted, restricted or overturning at inner tire. So if we draw the graphs of the above four inequalities, then we see that the safe region can be further trimmed to be as below. For Vmax, theta max less than tan inverse blah blah blah. For V minimum is equal to 0, tan theta max is equal to tan inverse mu k. The optical angle of superelevation that maximizes road safety for users is the one which is the smallest in the above four inequalities. Guys, if you compare my values with classical garbage by Newton, Laplace, whoever did it, you will see my values are more conservative and better for road safety. Subhanallah walhamdulillah wala ilaha illallah wallahu akbar wala hawla wala quwwata illa billahi al-aliyyil azim. Allahumma salli ala Muhammadin wa ala ali Muhammad. Allahumma hasibna hisaban yasira. Thanks for watching.